Chapter 10, Section 3, Inscribed Angles. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. The arc that lies on the interior of an inscribed angle and has endpoints on the angle is called the intercepted arc. In this circle, I have an inscribed angle. It is an inscribed angle because the vertex is on the circle. If you look on the interior of the inscribed angle, at the points inside on the interior on the circle, that would be the intercepted arc. And then these two segments of the sides of the angle would be chords of the circle. The measure of an inscribed angle. If an angle is inscribed in a circle, then its measure is half the measure of its intercepted arc. An intercepted arc is twice the measure of the inscribed circle. If you look at this example, it says find the measure of the arc or angle. A asks us to find the measure of ADC. Notice ADC is going to be a semicircle, so I actually already know that it's 180 degrees. But using the idea of an inscribed angle and intercepted arc, I can look at the inscribed angle ABC, which would be intercepting arc ADC. Angle ABC measures 90 degrees. We would double that to find the measure of the intercepted arc ADC, and 90 times 2 is 180. Which we already knew since it was a semicircle, but using these new ideas that we've just talked about, you would do 90 times 2, which is 180. If you look at B, they ask us to find the measure of arc AC. Notice that angle ABC is 70 degrees, and it is an inscribed angle. The intercepted arc would be AC. We would double 70 to get 140. And then if you look at C, they ask us to find the measure of angle ABC, which it would be an inscribed angle. The intercepted arc of inscribed angle ABC measures 196. So what I need to do is I need to take that arc length, or arc measure, 196, and divide it by 2, which gives me 98 degrees for the measure of the inscribed angle ABC. This next example says find the measure of angle ABE, the measure of angle ACE, and the measure of angle ADE. First, let's look at ABE. Notice that angle ABE is intercepting arc AE, which has a measure of 90 degrees. Angle ABE is an inscribed angle, which means it's going to be half the measure of the intercepted arc. Because the arc is 90 degrees, the measure of angle ABE is going to be half of that, which is 45. Next, let's look at angle ACE. Again, I have an inscribed angle because the vertex C is on the circle. This angle is intercepting arc AE also, which still measures 90 degrees. So I need to take half of that, which gives me 45 degrees. Now let's look at angle ADE. Again, it's an inscribed angle, and this time again it is intercepting arc AE, which is 90 degrees. So the inscribed angle would be half of 90, which is 45. Notice all three of these angles were intercepting arc AE. This next theorem follows closely to the example that we just did. It says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. If you look at that last example that we did, we had 3 different angles which were all intercepting the same arc, which measured 90 degrees, and all 3 angles measured 45 degrees. And this theorem is saying that that's always going to be true. 2 angles that are inscribed and intercept the same arc are always going to have the same measure. This next example says that we are given that the measure of angle B is 44 degrees, and they ask us to find the measure of angle C. Because angle B and angle C are both intercepting arc AD, the two angles are congruent. So we can say that the measure of angle C is 44 degrees. Because the measure of angle B is 44 degrees, both of those angles are intercepting arc AD. The next theorem says, if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is the diameter, then it is going to be a right triangle. The angle opposite the diameter is the right angle. This example asks us to solve for x. Notice AB would be the diameter of this circle, and angle C would be opposite the diameter. Because angle C is opposite the diameter, we know that it has to be a 90-degree angle. So we can say that 3x equals 90. Divide both sides by 3, and you get x equals 30. The next theorem says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. This example asks us to solve for x and y. To solve for x first, notice that angle S is opposite angle U, which measures 85 degrees. We know that the measure of angle x plus 85 degrees needs to be supplementary, which means they equal 180 degrees. I need to take 180 and subtract 85, and I'm left with x equals 95. I'm going to use the same idea to find the measure of angle y. We know it's opposite angle R, which is 80 degrees. So we can say y plus 80 equals 180. Subtract both sides by 80, and you get y equals 100. This next example says in the diagram, ABCD is inscribed in circle P. Find the measure of each angle. In this case, when I look at my opposite angles, I have angle A and angle C would be opposite, and angle B and angle D are going to be opposite. I know that when I add the sum of my opposite angles, they need to equal 180 because this quadrilateral has been inscribed in circle P, meaning all four angles are on the circle. When I set those two equations up, I'm going to get 19y plus 22x equals 180. And I'm also going to have 10y plus 40x equals 180. My goal here is to solve for x and y so that I can find the measure of each angle. To do that, I need to solve this system of equations. You've talked about system of equations in Algebra 1 last year. We're going to solve this system using the substitution method, which means for one of those equations, 19y plus 22x equals 180 or 10y plus 40x equals 180, we need to solve for one variable. And then we're going to be able to plug that into the other equation and solve for a variable. So what I'm going to do is I'm going to take the 10y plus 40x equals 180, and I'm going to solve for y because that's going to be a nice number and I'm not going to have to deal with any decimals or anything. The first step to solve for y would be to subtract 40x from both sides. So I would have 10y equals 180 minus 40x. Then I need to divide everything by 10. 10y divided by 10 would just be y. 180 divided by 10 is 18. And 40x divided by 10 is 4x. What I now need to do is I now need to take y equals 18 minus 4x, and I need to take it and plug it into the first equation, 19y plus 22x equals 180. When I do that, I'm going to have 19, and I substitute in 18 minus 4x for y, so 19 times 18 minus 4x plus 22x equals 180. Distribute your 19, and you get 342 minus 76x plus 22x equals 180. I'm going to go ahead and I'm going to combine my like terms and subtract 42 from both sides, and I get negative 54x equals negative 162. Divide both sides by negative 54 and you get x equals 3. Now that I have x equal to 3, I need to choose one of those equations to plug in 3 for x and solve for y. I'm going to go ahead and I'm going to use the equation that I solved for y equals 18 minus 4x, and I'm going to plug in 3 for x, so y equals 18 minus 4 times 3. Well, 4 times 3 is 12, and 18 minus 12 is 6. So we have x equals 3 and y equals 6. But I am not done yet because it actually asked us to find the measure of each angle. Well, if x equals 3 and y equals 6, we're going to be able to plug in for all 4 of those angles. I'm going to be able to plug in 3 for x and 6 for y. The measure of angle A would be 10 times 6, which is 60. The measure of angle B would be 19 times 6, which is 114. The measure of angle C would be 40 times 3, which is 120. And the measure of angle D would be 22 times 3, which is 66. If you notice, A and C were supposed to be supplementary because they are opposite, and when we add 60 plus 120, we do get 180. And for B and D, we get 114 and 66, and when we add those together, again, they're supplementary because they have a sum of 180. So I've checked my answer. I've given all of the angles of each the measure of each angle, and I am certain that those are the correct answers because they are supplementary. Today's assignment is page 617. It's numbers 9 through 29 all.